Does the way you enter or exit your material matter? And does it affect the part finish? Let's find out. Chuck Shive here with Onsrud's Chips and Tips. Today we're going to talk about lead ins and lead outs, or ramping in or ramping out. Now, these are pretty well known in the world of CNC routers. This is something we go through with all of our customers because they are essential for great smooth cuts and they help reduce material waste. We can save ourselves a lot of time and money by doing it right the first time. New operators or programmers usually start out programming their tool paths to go directly to a coordinate and then start cutting. This is called a plunge cut, when the tool enters the material straight downward and retracts straight upward. This places a lot of cutting force on the center of the tool, which builds up heat. And when you're pocketing, the chips are compacted into the base of the cut, which also causes heat buildup. Not only does this heat impact tool life, it can even leave burn marks, and those upward forces are not good for your spindle either. Here you see we have chatter marks, or you may know them as tool marks or dwell marks. These are the imperfections caused by the tool as it enters the material when plunging straight down. By using ramp in or lead in motion, your transition is much smoother. Here the tool enters the material at a shallow angle and gradually lowers through the cut path until it reaches your final depth. Unlike straight plunging, the cutting force is spread across the section of the flute, which reduces the shock. This helps extend tool life and helps reduce those vertical force loads to the spindle. There are a few types of lead in or ramping methods. Let's take a look at the ramping methods. The smooth ramp lowers itself until it gets to the first pass depth, as you just saw. With a zigzag ramp, the cutting tool lowers itself to half of the depth, then reverses and lowers itself down to the remainder of the depth, like a zigzag. This is especially valuable for high-speed pocketing. We also have the helical interpolation. Here the bit lowers in a gradual descending spiral pattern until it reaches the final part depth. This cut tends to reduce wear, and it's valuable when you're drilling or pocketing those deep holes. In addition to creating a smoother cut compared to plunging, ramping provides better chip evacuation, which reduces heat and again helps with tool life. Now let's look at lead ins and lead outs. A lead in starts outside of your workpiece, then cuts into your material. It then moves at an arc or straight line into your cut path. This way your scrap material takes the stress from the initial entry. A lead out does the same thing, but only in reverse. Although the finished edge is perfect, this method is not as efficient since you are covering more distance and retracing steps. However, when you're working with fibrous or layered materials such as melamine or plywood, a lead in and lead out is a very effective way to get high quality results. Just be careful that your start points and end points aren't interfering with any of your other parts. Now, if you have any fun stories about your first time using one of these methods, feel free to leave a comment below. And don't forget to be sure to subscribe and turn on those notifications. Until next time, be safe, stay healthy. I'm Chuck Shive. Thanks for tuning in.